Alrighty, ladies and gentlemen, welcome back. So I figured that we'd take a look at one problem here and how to use the angle bisector theorem in a slightly more complex problem here. This problem is on the back of your handout here. This is problem number 4, and this is a solution for that problem. This problem actually comes to us from the 2009 AMC 12B contest, and this is problem number 16 on that contest here. So I'll show you basically a way of thinking about how to do this here and setting it all up. Okay, so we have a trapezoid, ABCD. AD is parallel to BC. Okay, so I'm going to label it. Here's AD and BC being parallel. BD is 1, all right. ABD is 23 degrees, interesting. And BDC is 46. Okay. The ratio BC to AD is 9 to 5. Compute CD. So I'm going to write this as 9x, and I'm going to write this as 5x. And our goal is to calculate the length of CD. Now, the hint says, isn't there an angle that's begging to be bisected? Well, consider this here, ladies and gentlemen. This angle BDC is 46 degrees, and I note that that's exactly double 23. Now, that's a good thing, because, you know, if I split that in half, I'm going to create 23-degree angles, and lots of congruent angles generally mean good things for us. So I'm going to split this in half, okay? I'm going to create a line segment through D, and I'm going to bisect this angle. So this angle is going to go up. I'm going to put this point up here. I'll call this here Q. So in this situation here, this is Q, this is 23, and this is 23. Now, first things first, we note, okay, that's really good. So now what do you know about QD now? Well, let's see. QD here is a 23-degree angle right here. There's also a 23-degree angle over here. So notice that what we have here, ladies and gentlemen, BA and QD are now parallel to one another. Wait, if BA and QD are parallel, we know BC and AD are parallel because this is from a trapezoid here. This means that BADQ, so first thing we know is that BADQ is a parallelogram, right? Because it's got two pairs of parallel sides. Now, that's great because this AD, therefore, can now be transferred up here. So this 9x is really, you know, BQ and AD have the same length, so I'm going to call this 5x here. And that 9x means that QC is 4x here. Oh, wonderful. That's great. Now, notice that we have CD, that's our goal, and we have BD as 1. So now, wait a minute, now we look at triangle BDC here. This triangle, as you can see, this DQ is an angle bisector. It splits this angle exactly in half. So as a result, okay, this means I can use the angle bisector theorem. So therefore, we can say by angle bisector theorem, okay, by angle bisector theorem, we now know that I can write that BD over BQ equals CD over CQ, right? So we can compare this to the side on the piece underneath it, this to the piece underneath it, or you can compare the two sides and make that also as well. All right, so let's fill in what we know. Well, BD is 1, BQ is 5x, is equal to CD over CQ, and CQ is 4x. Oh, that's nice. So we can just solve for CD now. So in this situation, we can cross multiply, right? Or product of means equals product of extremes. We get 4x is equal to 5x times CD here. So to get CD, I just divide by 5x on both sides. This goes away, and we're left with CD is equal to 4x or 5x. But wait a minute, the x's drop out because these are not zero. These are non-zero multipliers. So the CD, therefore, has a length of 4/5.